In this video, I will go through the process of integrating ChatGPT with a Phoenix application using LiveView for real-time updates. It is, fortunately, very easy to get started with, but it requires that you have an OpenAI account with API access. There are also other LLM providers that this tutorial should work with. In my example, I have instructed the chatbot to only answer questions about Elixir-related topics. In a future video, I will go through how you can expand on this and provide the chatbot with content that it will use in the conversation. I will start by creating a minimal live view. This live view will be separate, meaning it will not be the entire page. The live view will just be the chat window and can then be mounted in the template, so it's available on every page. I have the option to set the container DOM element and the attributes. I am adding the Tailwind classes, so it will be positioned in the lower right corner of the page. The only thing that I want the live view to do is to render some hard-coded content. I can do that either in a separate template file or in a render function, like I do here. Right now, I'm only adding the minimum amount of markup needed and will fill in with the dynamic elements a little later. Currently, I am missing the form to create messages and also a way to display them. To be able to see what I have, I need to mount the live view in a template or in a specific page. In this case, I add it to the root layout, so it's visible on every page. Note here that I need to pass in an ID. I also have the option to pass in session variables, for example, the current user ID, so I can load the current user from the database in the live view. The initial version of the chat window will now appear in the bottom right corner. However, it misses the form to add messages and store them in the database. So next, I will add the backend functionality needed for that. Phoenix comes with several built-in generators with the purpose of adding boilerplate code. I will use one that only generates the database migration file and then a schema file that knows how to map the data with the database table. When I run the command, I pass in the name of the module, name of the database table, and the fields I want in the database. And when I press enter, the generator generates the two files needed. Before I run the migration, which results in the database changes taking effect, I want to make a small adjustment. The idea is that a user or website visitor can only have one active conversation. The conversation is considered active until we update it with a resolved @ timestamp. I can achieve this by adding a partial unique index based on the session ID. So I will just go ahead and add the line here. Beside the conversations being stored in the database, each message that we create will need to be stored as well. So in the terminal, I can run the generator command again, but this time for the messages. Note that I specify that the conversation ID references the conversations table. The other two fields that I generated was the role and the content. The role will be either the user or the assistant. Before I apply the database changes, I want to make a small change first. Since I specified that the messages have the conversation ID field, which has a database reference to the conversations table, I have the option to decide what should happen to the messages if a conversation is deleted. If I leave it like this, I basically can't delete the conversation. However, I can decide to set the conversation ID to nil, which makes them orphans in the database. But in this scenario, I want to go with delete all, which deletes the messages when the conversation that they belong to is deleted. With the changes to the migration files done, there is only a matter of running the migration to apply the changes to the database. This is the schema module I just generated for managing conversations in our chatbot. The purpose of a schema module is to inform the application how to map the conversation to the database. So the fields here usually map pretty closely to the fields in the migration file. Now, I want to specify a relationship where each conversation can have many messages, so I'll add a has many messages association to the schema. Also, since a user can only have one active conversation at a time, the resolved it field is not essential up front, so I'll remove it from the required attributes in the changeset function. The other schema module that I also just generated is for mapping to the messages database table. I want to establish a relationship between each message and a conversation, so I'll replace the conversation ID field with a belongs to conversation association, linking it directly to the conversation module. This change illustrates conceptually how messages are related to their conversations. There is one more thing I need to do before I can interact with the database. I need to create a module that contains the functions needed for reading and creating the conversation and messages. The first function will be responsible for finding or creating an active conversation based on the session ID that I pass in. Note that the session ID needs to be a string, so I'm converting it to one here. Otherwise, the database query might not work properly. I will query for an existing conversation for the session ID that has not been marked as resolved. If I don't find one, I will then create it. Otherwise, I will return the existing one. Next, I'll add functions for handling messages within a conversation. The list messages function takes a conversation as an argument to fetch all messages linked to it, ordered by their creation. This aligns with the schema change, where I established the belongs to association, ensuring each message is tied to a specific conversation. For creating messages, I use the create message function, which also takes the conversation as a parameter. This is needed because I want to associate each new message with its conversation using the put association function. What that does is setting the correct conversation ID on the messages row in the database. The last function here will be used when I wire up the form that makes it possible for a user to create a new message. This is what I will work on now. Even though the form is pretty simple, it is customary to break it out into its own component. And if you're new to LiveView, a live component is a reusable part of the LiveView, but it shares the same process. The update function handles the arguments, or parameters, passed into the component from the LiveView. In this case, the only argument I need is the current conversation when saving the message. I will pass that in when I mount this component. Since this is a form backed by a change set, I create a new change set based on an empty message struct. And as you soon will see, I'll let LiveView manage the input field's value. That is why I'm assigning the content variable here to start as an empty string. The HTML for the form is straightforward. I'm specifying that the change and submit events should be handled by this live component. Notice that I use the content variable for setting the value in the input field. Every time the user types, that value gets updated. The reason I do this is to easily clear the field again when the form is submitted. Usually, the form would clear because it disappears from the DOM through a redirect when the user submits. When the user submits, there are a few things to note. I add the user role to the params, since only a user will use this form. I'm also passing in the conversation, so the message gets attached correctly. The last thing I do is implement notify parent, which sends a message back to the parent LiveView once the form is submitted and the message is saved to the database. So, now I am back here in the Chatbot LiveView. It is time to connect some dots. The goal is to make the changes needed to create and display the messages. Every time the LiveView is initialized, I can use the mount function. Here, I start by calling get or create active conversation to either fetch or create an active conversation for the current user, using a hard-coded placeholder session ID for now. In a real-world scenario, you would pass in the user ID in the session params. I am opting to use the stream method to assign and display the messages in the template. That means that as soon as that are rendered, the LiveView will discard those records and not keep them in memory. The conversation record is something we can keep in memory, though. Then, I'll mount the form component I created earlier. Inside the template, I'll use a live component call to render the message form component, and note that I pass in the conversation that was required. The next change in the template is to output the messages. I need to mark the parent element as a stream, then it's just a matter of render each message as a chat bubble. I make two variants depending on if the role is the user or assistant. Remember that I added a functionality in the form to notify the parent LiveView when the message was created. I will use that to react on the incoming message and directly add it to the message stream. I should now have a working one-sided chat feature. I can test this by going to the browser and type a message and press enter. The only part missing now is connection to the chat API and generating an AI response. There are several ways to connect to OpenAI's API, and you can argue that I don't need to add a package. However, I do like this particular one. It is called Instructor, so I add the latest version of it to my mix file. And then, in the terminal, install it with the mixdeps get command. Before I can use the package, I need to provide it with my credentials. I have already added them to my environment variables, so I can reference them here in the configuration. When editing the configuration file, remember to restart the server. The way the instructor library works is it tries to enforce the LLM to return structured JSON that maps to an ecto schema. Therefore, I need to define an embedded schema and specify my fields and types. I am also adding validation for the fields that will help with obtaining the correct data format. In the call function, I will pass in the list of messages that were previously generated for the conversation. When making the function call, I can specify the model version and the specific ecto schema that we defined above. I will also specify the number of retries in case the LLM returns a failed or hallucinated answer. The system message is a good way to provide some guardrails so the conversation doesn't get out of hand. If you need it for something else than Elixir-related topics, then adjust it after your own needs. To be able to use the new chat module, I need to integrate it into the Chatbot module where I create and list the messages. I am calling the new function GenerateResponse, and it takes the conversation as an argument. I will list all existing messages in the order of the most recent messages last. A good idea here would be to add a limit so we don't send too much data, since you usually pay per how much data you send. But I will skip that for now. When I call the new chat module and get a successful response back, I append the assistant role to it and store the message to the conversation. The next step is to call this function from the LiveView. As you probably already figured out, I need to call this new function to generate a response as soon as the other message is created. Even though I am already in an async process, I want the message coming from the form to be displayed instantly. Therefore, I spawn a new async process with the startAsync function. To be able to catch the outcome and display the response, there is a handleAsync function. I need to make sure I name it the same as above, and as soon as an AI-generated response is created, it will end up here, and I can append it to the messages in the DOM. I also have the ability to catch an error, for example, if the connection to OpenAI fails. Then, I can make a fake message and append it to the DOM. I need to generate a unique ID based on the current timestamp in case there are more than one error in the conversation. When I test this again and write and ask about something Elixir related, I do indeed get a chatbot response. And to be honest, I still think this is cool. But there are still a few minor things I can do to improve the user experience. For example, I want each new message to scroll down to bottom so the user noticed them coming in. This means that I need to do a few more tweaks in the Chatbot LiveView. I want to disable to form as soon as I have posted a message and waiting for a result. So I'm adding the async result primitive to the LiveView and start with its default state. Then, when a user-generated message is created and added, I set the state to loading, and as soon as a response has been generated, the state can be resolved with an OK. In the template, I only need to do an if-else statement and display a dummy input field that is disabled when the state is loading. The last thing I want to add is the scroll into view feature I mentioned. That is something that I need a little help with JavaScript for. So I use the Phoenix-mounted DOM binding to dispatch an event as soon as a new message has been added. In the app.js file, I can add an event listener that reacts on that event and scroll the event into view in a nice manner. With the last changes in place, I can now see both the new loading state and the smooth scroll effect when a message is added to the chat window. And there you have it, a fully functional chatbot interface built almost entirely with Phoenix LiveView. In future videos, I will dive deeper into interacting with chatbots and using them to elevate the user experience in Phoenix applications.